Okay, Project N Math 121. And, we have Jupyter notebooks. We've been talking about it for a while. We've been talking about using a terminal. And the bottom line is, I would say that, the point of using Sage is, at this stage here, is sure to look, how does it relate to what you're doing with paper and pencil? So, they give you a problem over here. And, I don't know if I type in all the code for you, but I want to point out some of the stuff here, stuff that we've done in the past, in the 119 projects, 120 projects, that if you have the past experience with Sage, you're kind of building on things, but you might forget things. I'm not saying you won't. But anyway, what over here, just looking at the code, reset, X and Y, two variables. I define an equation to be this equation over here. All right, got this one over here. I do an implicit plot. What I want to just briefly go to is a different piece of software. All right, I'm going to go to Grapher. And what I'm going to do is I'm going to type in this thing here, which is x cubed. Then it says plus y cubed. And the reason I want to show you different software, I think the more tools you have at your disposal, the better it is for you. All right, the better it is for you. All right, so I get a nice little graph, pretty quick. Wasn't kind of painless to do, by the way. And I get an image over there. So the deal about this one over here is that, yeah, Sage can do it too. But it's a little more coding involved, by the way. I also want to point out that Sage can solve for y, and that's incredible, by the way. I mean, honestly, it's a cubic. It's a cubic. It comes up with three separate solutions on here. Now, someone says, if you were to graph those three separate solutions out, would it generate that curve? Well, that's the whole point of it. It should generate that curve in three sections, in three separate pieces, by the way. All right. So I'm going to say over there, another thing you could do in Sage is you can define a function not of one variable, but of two variables. Right. What am I talking about over here? This over here, you could describe this as a function of two letters, x and y. And that's all I'm doing over here. All right. And then, I could say y is a function, right? I'm saying y is a function of x, and sort of like differentiate it. Granted, what is this all about? Your ability to be able to do implicit differentiation. I got to be honest with you, though. You got to be able to do this stuff by hand, by the way. But it's nice to know there's a bridge over to using something else, right? You can do something else, right? But anyway, doing it by hand, I got this derivative over here. And you may want to take a look at the relationship between that Sage code and this one over here, all right? So I want to point out that it's not a bad thing to be looking at. And we've talked about all this code before, by the way. How to access solutions, right-hand side, left-hand side, yada, 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 and we've done that, all right? So it's important you read through that stuff. By the way, they give you other nice-looking curves over here, and what I mean by that, I just want to go to Sage briefly, and what I mean by that, hopefully you're learning some things about how to do a graph. All right, now I just gave you an example of doing something with Grapher, but what I want to do is I want to go to Sage, and I'm going to clear this out, and I'm going to define variables, reset, and I'm going to say x and y are variables. X a variable and y is a variable. And let's do this here, and whoops, let's see what I did wrong. Oh, I didn't define the equation. I got to define the equation. You know what I'm going to do? I'm going to type the equation in. And what's the equation? Let me scroll that up a little bit. X cubed, right? Plus y cubed. Minus 6. Yep, star x, star y, double equal sign 0. And now I graphed it out. Now, granted, someone might say, is that the same graph you got with Grapher? It is. What's missing is the XY axis. But I get the picture. And it's nice to have a picture. Granted, if I did it by hand, it would take me a lot more time. I might get confused, yada, yada, yada. This is nice to have, all right? So what I want to do is I'm trying to learn. Let me close this out. And part of learning is practicing, all right? So what I'd like to do is practice. I'd like to practice these pictures over here. And let me just see if I can do that. And I got pre-existing code, right? So let me see if I can do that. And I'm going to just go back over here. And I'm going to start to erase this and type in this function here. And what's that function going to be? Y squared, double equal signs, x cubed, star, 2 minus x. And by the way, someone says you can change the domain and range of that. I might have to, but right now, you know what? I'm seeing a picture over here, but I want to change it. And I'm going to say, it looks like it's a little bit below 0 and a little bit above 2. So let me just do that. I'll get another picture for you. And this is part of your playing, that you're just playing around. I'm going to say minus 0.1 and 2.2, or 2.1. Whoops, I don't want to do that. Sorry about that. All right, I got that. And it kind of boxy looking, rectangular. And I'm going to go for the y. So I'm going to go between, I don't know, it looks like about minus 1.5. Let me do that. And again, we're just playing around. And I'm getting a better picture now, all right? So that's not bad, I can do that. You know, I hope you realize that there's a horizontal tangent here, vertical tangent over here, and over here an undefined derivative over here, sharp corner, all right, sharp corner. What are they claiming over here, though? If you look at it, and again, what they claim, you should be able to find 2 points where there's a horizontal tangent, and they say at 1.5. Well, you know what? I'm seeing it, 1.5 horizontal tangent, and again, I'm seeing 1.5 horizontal tangent. They also say 1 vertical tangent at y equals 0. Let me see. I'm not really seeing that at y equals 0. Let me take a look at that. Oh, no, I am. It's right over here. Right over here, right? There's also a point where the derivative does not exist, and it's also at y equals 0, which is right over here. The derivative does not exist over there. Let's look at the next one. I'm going to close these out. And again, I'm trying to learn by doing, by practicing. Let me clear. Let me go over here, clear, C-L-E-A-R. And what I'm going to do is up arrow. And I want to put this second plot in. And again, I might be confused when I do it, and that's part of learning. And what's that going to be? Well, I'm going to scroll up a little bit. It's 2 star x squared plus y squared, quantity squared, double equal sign, 25 star x squared minus y squared. Close it out. And let's hit enter. You know, I'm not seeing everything, so I got to change my window. And I'm going to change the x's. I'm going to go, I don't know, let's try minus 5 to 5 now. Wow, looks like a figure 8, all right? And I think I went a little bit too far there. I'm going to minus 4 now. I'm going to change a little tiny bit. And again, what's nice about software, it's quick. That's a better picture. And certainly, you know, I want to read through it for you. It says, you should be able to find 4 points where there's a horizontal tangent. And they say plus or minus 5 quarters, which is, you know, 1.25. And let me take a look at that. 1.25. You know what? I think I might have copied something wrong over here. Let me take a look at this. 2 x squared plus y squared squared equals 25 x squared minus y squared. You should be able to find 4 points where there's a horizontal tangent. Oh, I'm sorry. They said y is plus or minus 5 quarters. And that's a different story. And that's the y value. And that's right over here. Yeah, I'm seeing that. Horizontal tangent, y is 5 quarters. Y is 5 quarters over here. And one, yeah, I'm seeing that. I'm definitely seeing that. And then it goes on. Let me keep reading it. And 2 verticals where y is 0. And y is 0. Yeah, I'm seeing a vertical tangent there and a vertical tangent over here. Not bad. Let's do the next one. And again, I'm reading and I'm looking, seeing what I'm learning. All right. Let me close these things out. And let me do the next one. And again, I'll change the domain and range of that in a second when I need to. and I'm not giving it much thought. I'm letting my software do all the hard work for me. No thinking whatsoever. Y squared is equal, that's a double equal sign, by the way, 5 star x to the 4th power minus x squared. All right, hit return. Whoops, something happened there. And I got to see what happened. And I think I know what happened. I did not delete something. When I hit the return button and something weird happens, I know I've done something strange over here. Now, by the way, I'm looking at it and I'm thinking to myself is, you know what, I gotta change the y's, right? I wonder what's going on there, but let me change the y values, and I'm gonna go -5 to 5. Well, I'm getting a better picture over here. Now I'm gonna change the x values, and let me do that for you. I didn't mean to do that. Go back over here. Looks like I'm going to say about, I don't know, I'm going to say -2.5. And let's see what happens now. Sort of a better picture here. So let's take a look at it. You should be able to find 2 points where there is a vertical tangent, and they say that occurs at y equals 0. This is y equals 0. And I'm kind of seeing that over here. Now, I could zoom into that to make it look better, but right now I'm kind of agreeing with that. And it goes on, and let's just, and there's also a point where the derivative does not exist at y equals 0. You know what? I'm not really seeing it. So what I need to do is I think I need to go to Grapher. All right? I really want to go to Grapher, and I'll tell you why I want to go to Grapher. I'm looking at this thing over here, and I'm thinking to myself is, I don't want to keep playing around the demand and range. Grapher is going to be much faster for me. So let me go to Grapher. Got to find it first. And I'm gonna get rid of the equal sign, the double equal sign. I just did a copy paste, by the way. I get rid of the star. I don't need the star there. It looks kind of crazy anyway. Let me kind of zoom out. You zoom in. And I want to read this carefully. And I want to see if I copied it in right. So y squared is equal 5x4 minus x squared. You should be able to find 2 points where there is a vertical tangent, y equals 0. Well, this is a much finer graph over here. And y equals 0, I'm definitely seeing vertical tangents over here. There is also a point where the derivative does not exist, where y equals 0. And you know what? I'm not seeing it, but there must be something over here. So let me do something here. Let me accent grid. I'm going to get rid of everything. The frame here. Let's see. You should be able to find 2 points where there's a vertical tangent. I did that. There's also a point where the derivative does not exist, where y is equal to 0. Now I know. Yeah, it took time to think about it. And what I want to point out is it's something I'm not seeing in the graph, by the way. But there is a point that satisfies this, and the point would be 0, 0. So, for example, 0, 0 would certainly be satisfied, but there is no derivative at 0, 0. So I want to, again, go back to the grapher thing over here. I'm not seeing the point at 0, 0, but there is a point here, 0, 0, that satisfies this over here, and there's no derivative there, all right? It's just a point, all right? Just a point. All right, a brief note here. I do believe that graphing helps initially, but software without reason, well, you know what? This is a good example. Without me thinking, I would not have known that. I had to think about it, and I saw it written down. I thought about what they said. But software without reason, perhaps where most will fail to see the forest for the trees. So let's repeat that. Going back to my grapher, you know, I'm seeing the vertical tangents where y is 0, but I didn't see the point because it didn't even graph the point 0, 0. I don't know why I didn't graph the point, by the way, but there should be a point plotted there, all right? Now, granted, if I were creating a better picture over here, what I would do is I would do a new point set. And let me just go through that with you. I'm going to add these points out over here. And I'm going to plot a point for you. And by the way, you can do this in Sage too. So I would definitely plot that point out there. All right. I would plot the point. I'm saying there's a point there. All right. Okay. That's about it. Thanks so much for paying attention.